Recording is in progress. Okay, thank you. So now, what I'll cover in this today's session, right? There will be a 1.5 hour session, and what I mainly cover in this is so these are topics I'm going to cover, like why we should attend interview preparation session. Right? What is the requirement for that? So when you have already done a course, then what is the requirement, or you have just the experience of 1 year or 2 years, and if you are looking for a job switching, and why you want to attend this interview preparation. So what we cover in this. So then I'll also cover on some sample questions, right? Some sample tricky questions in industries, how to handle it. So then I'll also cover on some hands-on tool debugging, right? Like how to use a tool for different purpose. So I'll also cover on that. How to handle the different issues. Then I'll discuss on our interview preparation course structure. So I'm going to discuss about all these 4 aspects today. Right. So first I'll start with what is the need for interview preparation. So why we should use interview preparation, right? Why we should undergo interview preparation course. So the main reason to use interview preparation course is, see, we will cover real-time interview questions from easy to complex level. Right. We cover all the questions, like, see, we will be having a session for 4 days in a week. So in a 4 days in a week, 2 days will be weekdays and 2 days will be on weekends. It's Saturday and Sunday, and 2 days will be on weekdays. So in weekdays, easy questions will be covered, right? What are the easy questions? Like if you go with synthesis, right? What is synthesis? What are the inputs for synthesis? Right? What is a synthesis flow? What do you mean by elaboration? What do you mean by optimization? What do you mean by mapping? Right? Some easy questions will be covered during the weekdays on every topic. At the weekends, we cover some difficult questions which is asked in industry, like the questions are like, what do you mean by register read timing in synthesis? What do you mean by auto ungrouping in synthesis? What is the impact of auto ungrouping on timing, right? Which is better? So if you do flat synthesis, that is better, or if you do hierarchical synthesis, that is better, right? That is called as auto ungrouping. Which type of synthesis is better? So what is logical equivalence check after synthesis? How to do logical equivalence check after synthesis? So what is physical aware synthesis? So what is difference between physical aware synthesis and logical synthesis? Right? All these are some tricky questions as in industry on synthesis, right? Then we cover tricky questions on weekends, that is Saturday and Sunday. So each day 3 hours. So 6 hours during weekdays, 6 hours during weekend. So we will cover all the questions from easy to complex level on each topic. So at the last, I will share the schedule also. So next is, we also focus on real-time industry challenges. Right? Only teaching you people about the interview questions is not sufficient, right? We have to also teach you some industry challenges. What are the challenges you face in industry? What are the challenges you face and how do you handle it? Those type of things will be discussed at the end of interview preparation session. Right, and what challenges you should mention even in interviews. Some real-time challenges has been discussed. For example, like you have issues in closing timing, right? Interface closing timing. It is between 2 blocks. So as a block level engineer, what you should do? Right. So you have some issues in fixing the shorts, right? You're not able to fix the shorts because of the region is highly congested. Then how you should handle it? So if we have setup and hold violation in same path, then how to handle it? So those type of questions are discussed during this sessions, right? Like to understand the industry real-time challenges. Then third thing, we mainly focus on low technology issues also, because as you do the course, right, you people also always focus on like technologies like 28 nanometer or 45 nanometer. But there is a gap between lower technology and higher technology, right? When we compare to the lower tech, see, in higher technology, the cells are big and metal layers are wide, and the spacing between metal layers are enough, right? This will not create any issues. So what are the lower technology issues? Like lower technology issues are like, as cell is very small and metal layer width is thick and metal layer spacing is very small. So you have more crosstalk issues, more electron migration issues, and there is a double patterning technique in lower technology, right? For mask, for M1 layer, right, you have two colors, red color and green color. So once if you run the red color, right, adjacent to that, you should not run the green color. So like that, you have double patterning technique. You have many base layer issues. So what are the base layers issues and how to address during the thing, right? We will discuss on that also. And next is exploring different tool commands, right? That is very important as a PD engineer. See, industry has a flow, right? We need not to worry. Industry is having a flow. So flow will take you from the level of synthesis to the routing. You need not to worry. But what is requirement? What is the requirement of PD engineer is you should extract the information from the tool. So that is the main important for the PD engineer. So how to extract information from the tool, right? You should be knowing, if you go with synopsis tool, right? There is a objects, class, and attributes. And if you go with Innovus tools, then you have something like dbget commands, dbset commands. So how to use this dbget and dbset command to extract information from the tool? So those type of things is very much important for PD engineer, and that we will discuss during our interview preparation. For example, I'll tell you, I will give you a net. Right? I'll give you a net N1, and I'm asking you find on what layers this net is routed. Right? On what are all the layers this net is routed? Right? Find it. Then can anyone tell me what command you will use? Yeah. Can anyone tell me what is the command used? Anyone can tell? On what layers this entire net is routed? Okay, I have one net N2. Right? I'm having a net N2. So route this net with NDR, right? Applying NDR means double width and double spacing. And you should route only by using M5, M6, M7 layer. Right. So then what command you will use? How do you do it? See, recent interviews, client interviews by some companies like Qualcomm and all, right? The main focus is on the commands, right? What commands you use. You should be prepared for that. So they will give you the laptop and they will ask you to execute few commands and get the results from that. See, if you know the Innovus tool, that is fine. If you doesn't know Innovus tool, so if you have time, please learn Innovus tool also, because Innovus tool is very important. So Fusion compiler is also one of the competent tool, but industry more uses Innovus for physical design. There are other synopsis tools like Prime Time, Star RC. So that is very famous for timing STA. Right? Tempus is rarely used. Every company uses Prime Time and Star RC from Synopsys. For synthesis, if you use, right, every company uses a DC compiler or Fusion compiler from Synopsys. But when we come to physical design, many companies use Innovus. So what is dbget commands in Innovus? That you should be knowing. Then you should be knowing different flow related and flow control commands. So that is very important. For example, I'll ask you, do the routing, right? I'll ask you to do the routing like timing aware routing, right? So tool should do the routing in best possible timing, means whichever nets will come under the critical path, more violation path, it should route with less distance. So it should give importance for that nets. So timing aware routing, you do it. Then what control command, what flow control command you will use to enable that? So I'll tell that insert the tie cells, right? Add the tie cells. So what command you will use? Check the tap cells, right? Tap cell placement. You have tap cells and you have tap cell placement done, and what is the command you will use for tap cell placement checking, right? Those are called as flow control commands. So you should be knowing that. So you should for so to if you already know Innova's tool, that is fine, or else we will cover the Innova's tool flow control commands and different flow related commands. Then main thing at last, we also focus on automation using TCL to handle the complexity. So if you have 1,000 violations and you cannot be fixing one by one, right? You should be doing automation to fix the violations. So you should learn automation by using Tickle. So I will give you the file and I'll ask you get all the start points, right? The timing report. In the file you have all the timing reports, like 100 timing paths you have, and I'm telling get all the start points. So you cannot scroll down and you cannot copy one by one. So how fast the work you will do, right? That much time you can save, that much personal time you have. Or else you will end up with a situation where you cannot sleep at all, right? Industry has more complexity. So how much automation you learn. So that much time you save for your personal work. Or else it's very difficult to even sleep also. So we have that much complexity in the projects, right? So learn automation not only by using Tickle, also by using GVim or by using Unix commands. Learn the automation and do the things automated way. Don't do one by one, right? So for these reasons, we need an interview preparation. So the main challenges in industry. So we will cover all these points during our interview preparation course. So if you have any queries or doubts, you can ask me. Yeah. Any doubts you have? Okay, if you don't have any doubts, right, we will go to the next topic, like what is the main skill set required for PD engineers? So just this is a flash, right? So you should be knowing about the basics. So if you are a good PD engineer, then you should be knowing about the basics, right? What is the basics? Like digital basics, Unix, JVM, Tickle, right? CMOS and Verilog. At least you should be knowing how does the Verilog module looks. Right? These are the basics you should be knowing as a PD engineer, and you should be knowing a PD block level flow, right from synthesis to routing till sign off checks. So you should be knowing that, and you should be knowing STA, right? These are all the STA topics you should be knowing, like mainly what is net delay, cell delay, and setup and hold analysis, into reg, rest to out, PUT conditions, MCMM file, clock gating checks, handling asynchronous paths. And you should be knowing how to use EDA tool, right? At least one EDA tool you should be knowing, either from Synopsys or from Innovus. So if you know Innovus, you have greater advantage. So these four are compulsory, should be knowing to be a PD engineer. And these three things, right, whatever I am mentioning here, automation, lower technology issues, or full chip design, these are the additional, these are additional these are main requirement, the first four things. Other three things, if you have, this added advantage, right? If you have this knowledge, like if you know TCL automation, right? So you can do the work a little bit faster, you can handle in better way, and you can share the scripts in the team. So you can ask, okay, I have a script, it can do the work in better way, right? Then you will get the attention of the team, right? You will be your lead will recognize you, like you're doing the best work. For example, if you have 1,000 antenna violations, and for every antenna violation you have to add a diode, then if you're doing one by one, that is 1,000 times you have to do, that much patience and that much time you have to invest. So instead of that, if you have an automation method, then you can fix the 1,000 violations, antenna violations, by using Tickle code, right? That is helpful. Then what happens? So your lead will recognize you. So as industry is moving very fast in terms of automation, you should also move along with that. So next is the lower technology issues where you people are not aware when you are not part of industry, like multi-patterning, base layer issues, spacing issues, wire reliability issues, and you have signal integrity issues like crosstalk, EM, and IR drop issues, because the metal layer is very small, thickness is small, and spacing is less. Right? You will see all this signal integrity issues. And it's an added advantage that if you know full chip flow, right? Full chip design flow. So how to do partitioning, how to do IO pad placement, how to do block port placement from the full chip point of view. So integrating all the blocks, integrating feed through planning through the blocks. So bump assignment. So in the full chip, how to do bump assignment. Bump nothing but it's a ball-like structures. So that bumps will connect to your IO pads. And these IO pads will connect to your block ports. And there are other bumps like VDD VSS bumps. VDD VSS bumps will connect to straps. How to do this? Bump assignment and RDL routing. That is done. Bump assignment and RDL routing will connect your chip routing to the package, right? From the package and to your chip routing, right? In between you have bump and RDL. So how to do that? Then you have interface timing, right? So you will be handling rest to reg paths, but into reg and rest to outer, right? That is between two blocks. So how to handle that interface timing? So if you know all these things, you can become a full chip design engineer. There is a great advantage if you become a full chip design engineer, because it's not easy to become that. So these are the main skill set required for a PD engineer. First four things, right? You don't want all the seven. First four things is very much important. Automation is added advantage. So you can save your personal time and you can be recognized. So if you know automation, so lower technology issues. So when you work in real industry, you will automatically be part of lower technology issues. So you should handle it. So and full chip design, if you know, it's added advantage for you. So these are the main skill set required for a PD engineer to work in industry. So now, what should be your resume content, right? So when you complete your interview preparation, right? How to change your resume content? See, in the resume, just I have flashed this. So in the resume, first you will mention your name, your email ID, phone number, and your LinkedIn ID if you have, right? Then you will mention about your experience. So if you are experienced, this resume, whatever I am flashing is for a fresher. So if you have a experience or any training or internship details, right, that you can mention. And this internship should be compulsory, should be focused on VLSI only. If you have any other internship, please don't mention that. You can directly mention your training details. So how does your training has went and what you have done for a fresher? If you are applying as an experienced candidate, then this will be your experience details. So where you have worked and what a briefly what you have done there, right? And which tool you know. So next is what is your skill set? In which skills you are good, right? So you are good in, you know, the flow from synthesis to routing and sign off. So you are good in timing analysis, setup, hold. So every PD engineer should mention this both, right? Flow and timing analysis. And what are the tools you have handled during your project time? Which languages you know, like not languages means which technical languages you know, like Unix, JVM, Verilog, TCL, Python, right? All this knowledge, all this programming languages you know. And what are the concepts of basics you know, right? You know CMOS, you could be in CMOS, VLSI design, and you have a great knowledge of signal integrity issues like crosstalk, how to fix it, electron migration, how to fix it, IR drop issues, how to fix it. These things, what are the knowledge you have, right? Like that, you have to mention your skill set or your core competency. So next, you can mention two projects Right? This project 1 and project 2, two projects you can mention. See, this project is for fresher. So the project should compulsory contain one project at lower technology, even though you're fresher, right? So don't even mention project at 28 nanometer. Please mention at 14 nanometer. So 14 nanometer uses FinFETs, but the flow remains same, right? And first you will mention the project specification like block level physical design of GPRS packet data processing unit. So just you can mention block level physical design. That's it, right? You need to elaborate it. So sorry, here design word is missing. Right? What is the technology? What technology you are using? What is the operating frequency? How many macros you had in your design? What are standard cells? How many? And what is a metal layer? Which tools you have used in this project? Then what was your roles and responsibilities in this project? Like executed a complete planar flow, right? Through strategic macro placement. That every person will do. The same statement is hold good for everyone. Then what you have done? You have done CTS, right? Perform CTS with NDR rules, achieving minimum class Q and insertion delay. So next is analyze and fix setup and hold violation using prime time ECO flow. So that is, see, these points every engineer will undergo, right? ECO is one of the critical stage during the tape out. Every engineer should undergo this. So they should take ECOs and they should fix setup and hold from time to time. So you have performed LVS checks and cleared opens and shorts in the routing state. So, and you can also mention you have fixed DRCs also. And what challenges you faced, right? This is your roles and what was your roles? This was your role. But what are the challenges? So challenges, you have done multiple iteration of macro placement to reduce congestion and to achieve better QR, quality of results. So you have done macro placement multiple times for these 48 macros, and you have tested the quality of results in terms of congestion and timing. So which one is giving you the better result, right? That you have freezed as macro placement. So you have done multiple CTS experiment for timing closure, like you have conducted clock tree synthesis. Like first you are done with fishbone, next you went with H tree, or you went with multi-point CTS, right? Then which CTS gave you the better results of timing, right? Always it is not that H tree will give you the better result, right? Sometimes even fishbone can give you the better results, but H tree has added advantage. Right? So industry will ask you, okay, your timing is not good. So because you have a lot of skew, so then you better go for H tree. And as here in the roles and responsibilities, you are responsible for fixing the shorts, right? And here, what is the challenging is you have to fix some few shorts and DRCs manually. Because due to complexity, every issue is not fixed by tool. So in the training session, whatever training you have undergone, their tool will fix every violation because the complexity is less. The cell count will be in lakhs or 50,000. But industry, the cell count will be in lakhs of 10 lakhs or 15 lakhs. So every violation is not fixed by tool. So some of the violations you have to fix it manually by manually routing it. Then that can be challenging. So like that, you have to mention two projects. So mainly specification, your roles and responsibilities, and challenges in that project. So one project should be compulsory at lower technology. I'm mentioning this for a fresher. At least 14 nm, right? Not more. One project should be at 14 nm. So at last, right? At last, you can mention that what was your academic project for a fresher and what are their strengths and hobbies. And you can mention your personal details like what is your date of birth and city, in which city you are located, and at last you can mention the declaration. So this is how the resume format should be for a fresher. Mainly you have to mention two projects and a skill set. This is very important. We will not see any other things. So when we shortlist a resume, right, we will mainly see these projects. They should be carefully mentioned, and you can take advice of experts how to mention these projects. And these projects, no doubt, as a fresher, you're done in the institutes, training institutes, no issues. What you should mention, some little bits. See, for example, here you can see, right, I have mentioned one of the automated tickle script to fix a DRVs after routing stage. Means you have max cap, max trans violations, more violations, and you have not fixed one by one. You have written some tickle script to fix it, right? So if this type of things are mentioned in a challenges, right, that shows that you're different. So that has done some different things, and there can be a multiple questions on this. You may ask. So don't mention simply, but if you are good in tickle and other things, right, you can mention that. So this is your main resume content, right? So I want to mention what is the schedule for interview preparation. So before going to the schedule of interview preparation, right, I wanted to take some sample questions, and I will answer those questions. So before going to that, if you have any doubts, right, you can ask me.
Excuse me, sir.
Yeah, please tell me.
Yeah, can we add or like actually I'm working in another domain. Can we add that experience in resume?
No, you cannot add. Please don't mention that.
Okay. Thank you.
See, companies will nowhere look into that, right? You compulsory don't add it, any other experience. Please add only VLSI experience. If you don't have, also you take a suggestions from the expert, right? And you can mention some projects. Okay.
Okay, sir. Thank you.
Please don't add any experience on the other levels, right? Please don't do that.
Hello, sir.
Yeah.
Sir, actually, I done 2 years like worked in a non-technical job. Just I want to switch, like I'm a C background. I want to switch to the PD. And I took a
You
course.
have already done the course. See, this interview preparation course is for only the candidates who already done the course.
Yes, sir. Completed, sir. Course was done, sir.
Yeah, then you can switch it. You can talk to us personally, because we should know what is your age and all, right?
Okay, sir.
So based on that, we can suggest you. So you can do that. It's see, this is even I can mention that the persons are, rather than freshers, right? The person who is having the gap like this will be they can easily enter into industry with the good technical skills. That's it.
Okay, sir.
If you have good technical skills, you can easily go through.
Thank you, sir.
Hello, sir.
Yeah, please tell me.
Yes, sir. I had 3+ years experience in embedded C developer. So can I add it in my resume, or actually after that I was trained it as a PD?
No, it's of no use, right? So see, you are claiming the experience in physical. See, when you are already having year gap, so you should directly mention that you are a PD engineer for those many days. For example, you have a 6 years of experience in other domains. You should at least tell that you have 3 years of physical design experience and you should go to industry. So don't mention other experience, right? It's of no use.
Hello, sir.
Yeah.
Sir, as you mentioned over there that we should have a project of 14 nanometer of below that node, but in our institute they teach us 28 nanometer. So
no, see, I am mentioning. See, I see. Teaching is, see, institute can teach only at 28, right? Because see, what happens is industry works at 4 nanometer, 5 nanometer, because they will get those input files, right, or PDK files, process development kit, from the foundries. Okay, for example, Intel will get from Intel, and they have their own foundry, but still they will also purchase from TSMC. Okay.
Yes.
For TSMC, they pay in crores, right? Like they can purchase from TSMC. Okay, but institutes cannot do that. So they will train you at 28 only. But what you should do is you should mention in your resume that it is 14. Right? There is no float.
Yes, sir, it's correct. We can mention, but the challenges which we are facing for 14 nanometer will be different, and for 28 nanometer it will be different. But we have practiced for 28 nanometer what things we have faced over there. So while coming to 14 nanometer, some challenges will change, some technology will change, like FinFET we are using over there. So they
No,
can
it's
ask the
okay.
question on based on FinFET.
Using a FinFET inside a cell or MOSFET inside a cell will never affect the PD engineer.
Okay, sir.
So whatever they want, because that affects the layout engineer. So layout engineer
Yes.
is going to draw the layout. Right? We are nowhere related to that. But
Okay.
only for us, low technology issues will come, like as I mentioned here, right? So we have all these issues in the low technology. See, as because see, you know how to handle crosstalk in 28 also, correct?
Yes, sir. Yes.
But you will be having more crosstalk in low technology because as metal layers are very close to each other.
Close to each other. Yes.
EM violation. So you will get less EM violation in 28, but you will get more EM violation. What you should mention is these are the low technology issues. Right? That is what they will ask in interview.
Okay, so we should just mention that these things are there. We know how to solve all those things. If these
Yeah.
things will be coming, we will be able to solve all of these things.
If there is a electron migration, what is the solution? Solution is same in even in 28 or even in 14, right?
Shielding is
So
there.
increase the it is shielding is for crosstalk for EM
Oh, okay. Sorry, sir.
metal width.
Spacing,
You should
spacing.
increase the metal width, right?
Yes, sir.
Or reduce the resistance,
Yes,
right?
sir. So we should increase the width of the metal layer, so more flow will be there. So electromagnetism will be reduced over there.
Yeah.
Okay, sir. Okay.
Or use higher
Thank.
metal layers,
Yes, sir. Yes.
like that.
Thank you, sir.
So see, what I suggest is, see, I'm everyone if they mention 14, right? Everyone mentioned they have done it 28. You mentioned as 14. The flow almost remains same. Only few things will change. That is, you should be in a see. There is nothing to change in hands-on, right? The issues will be more or less. That is what it will. How that is how it will vary. But how do you answer? See, for example, you have used 14 nanometer. So what was the difference? It was a FinFET technology, right? And the thing is, 14 nanometer doesn't have any double patterning, right? Double patterning will come only at 7 nanometer, like this multi patterning of metal layers. So, but you have other issues like base layer issues. Base layer means so base layer issues in the sense is the layers which is lesser than M naught. You have least metal layer is M1, and below M1, what are the layers is there? Those are called as base layers. So, what are the base layers issues you will get? So I can mention one or two base layers issues, right? What is like, uh, yeah, just I will take I'll just a few discuss on some questions on interview so that you will get understand like how to answer, right? So
Excuse me, sir.
yeah, please tell me.
Actually, I am working in previously 3 months in one company.
Hmm.
After that, they told they didn't want a additional step. As I'm an intern, I quit earlier. At the time, I have a PF account in that company. Is there any issue?
See, PF account will come into picture when see all those things we cannot discuss here. You can talk with this person, okay? Because the
Okay.
session is recorded. Okay.
Okay.
See, this any personal things you have, please you discuss with us. You call to our admin, he will connect with me. Okay. See, you have any technical queries, you discuss any personal things you have, please discuss with us. We will discuss with you because the session is recorded. Okay. So I can tell that see everything has a solution. Right? You can use it, but only it should be technically strong. See, many companies know that you have experience in other domains, still they will take you. But if only if you are technically strong, that is what I can mention. So every company will not go for background verification. They will not waste in time in if you are skilled. So they will not waste time in background verification. And few companies, they even though you are very good, the skill is very good, but still they will follow the rules. So they will go for background verification, very strict. So skip those companies. if you have any issues. That is what I can mention.
Okay, sir.
So you have two or both the options. Right? So some companies will have strict background verification even though you're very good. So then skip those companies. The background verification happens completes after 3 months you joining. Right? They'll take at least 1 or 2 months to do background verification after you joining. Right? After that, if they found out, then it's problem for you. Then you should skip that type of companies. And there are few companies who knows that you are not from proper domain, and because during interview only we can make out, but still they will hire you because they know that you have talent. Right? That is also there. So I'll just take few questions, right? What is the difference in physical aware synthesis and logical synthesis? So second thing is get a routing layers of all nets. Right? Third thing, methods to fix antenna violation. Fourth thing, how to handle timing if setup and hold violation is seen in same path. If you want better timing, where you will add or will go for better power, where you will add your clock gate. What is necessary for why bounds? Explain some scenarios where we can use bounds. And hard placement blockage. So how to fix crisscross connections? In macros, in SRAM, how to fix crisscross connection in SRAM? Even though crisscross connection exists after clipping. All right. What is a double patterning technique? What is double patterning technique. Okay, so we will answer these questions, right? Then we will discuss on the interview preparation schedule, right? So the first question is, explain difference in physical aware synthesis and logical synthesis. Any answer? Anyone can discuss on this?
Logical synthesis means it's from RTL to gate level netlist. It doesn't contain any physical informations like def file and left file. And physical aware synthesis will get the def file informations like macro placements and all. After getting the floor plan DB, again we have to run the synthesis.
Very good, excellent answer, correct answer. Then why we should go for physical aware synthesis?
Because if we do the logical synthesis, we don't know the placement, macro placements and all. After placing the macros, if we run the synthesis means we'll get the exact locations of macros and all. So it will reduce the timing and all.
So what is the
I think.
advantage of that, right? If we know the macro placement, everything, right? What is the advantage? How timing improves?
We'll get the exact net delays values from those left and def files.
How do you get delay values exactly?
Like, sir, physical aware synthesis has the information of the congestion, and with that thing, that macro placement will be like, we can do it.
We'll have all the QRC tech files where we have the RNC values in the files.
Then what happens in logical synthesis?
Without using these tech files and left files, we will implement that logic synthesis.
How
Sir,
does the timing varies in that both?
in logical synthesis, we usually use wire load model to estimate how much the RC delay might be there. But in physical aware synthesis, we have a better correlation we know where the macros and all set. So we'll have a better correlation to what we end up with. So it will be better than
Yeah,
using
exactly, right? The same, very good answer, right? This is the exact answer. So why, first is like, why we should go for this, right? That is the question. So why we should go for this?
Sir, actually, physical aware synthesis you want to do, first we will do logic synthesis and then only will possible to do physical aware synthesis. So that's why you will get the better PPA. Not only performance, you will focus on power and area also. So that's why we will do for physical aware synthesis to better PPA.
Yeah. So now I can just mention that, right? What is a logical synthesis, right? Logical synthesis is nothing but logical synthesis. In logical synthesis, synthesis is done without floor plan information or physical information, right? I can mention without floor plan information or physical information. Right? So in logical synthesis, what happens is, so you have a steps, right? Like during logical synthesis, you have steps like read. What is the steps, right? Read RTL. So next is you have elaborate. The step is elaborate. So next you have mapping. Next you have optimization. Right? Optimization means improve the design in terms of power, area, and timing. These are the steps in logical synthesis. These are the steps. So during optimization, right? So tool should get a cell delay and net delay during this optimization. Then only it can do the optimization in terms of timing. So you will get a cell delay from the dot lip and net delay, right? The tool will get a net delay from RC values of the net. And that RC values of the net is obtained from wire load model. That is not accurate. Right? So I can mention here during optimization, right? During optimization, tool gets net delay from wire load model which is not accurate. See to get the actual net delay, right? You should be having, to get actual net delay, you should be knowing where the cells are placed. Then you can use a QRC tech table, or you can use the TLU plus file. You can get actual, for example, if you want to get so if you have a floor plan like this, and if you have a cells, right, and if you know what is the actual, if the cells are placed, right, then this is a metal layer connecting from one cell to another cell. If you know what is the net length and what are the layers used for connection, for making the connection, what are the layers used and what is the actual net length. So if you know this, then you can easily get RC values from TLU plus file, from synopsis, or from QRC file, from cadence. So this is having accuracy of the net delay, right? So because we are calculating RC values by using TLU plus or QRC, which requires a net length. What is a net length and what layers are used to route? So after placement stage, right, even though routing is not happened, but we have global routing. Global routing means estimation of real routing. So how the real routing happens is that estimation we can do by using global routing. So by using global routing, we can do estimation, we can get the net length, what are the layers used, and from using TLU plus or QRC file, we can get RC values of a net. So this has more accuracy. So to happen this, right, you should be, placement should be done first. So placement should happen first. But during the logical synthesis, placement is not happened, right? So you cannot get RC values by this method. So for that reason, what we do, we depend upon the wire load model, which is in .lib, which is not accurate. So wire load model estimate the net length based on the fan out of a cell. So because of that correlation between logical synthesis and final routing stage is weak, right? So your synthesis, after synthesis, you may have better timing, right? Your tool will not do much optimization. Your tool will not do much optimization because it's seeing better timing, because net delay is obtained from the wire load model. So logic synthesis was good for higher technology, because higher technology net delay was not important. So net delay was almost very less compared to cell delay. But during, when we go for lower technologies, right, net delay is almost equivalent to cell delay. So we cannot ignore the cell delay. So for that reason, what we did is we went with physical aware synthesis. So in physical aware synthesis, so floor plan information is given to the tool, to synthesis tool. So what happens during physical aware synthesis? So during optimization, right? So during optimization, as you already have floor plan information. So what do you mean by floor plan information? Floor plan information means what is the core area, die area, right? What is core area, die area, and where your ports are placed. Right? These ports you have, correct? So where these ports are placed. So ports placement information and your macro placement. So how the macros are placed, right? This macro placement information. And the power planning also done, right? Those till power planning done. So this information of tap cell placement, end cap cell placement, D cap cell placement, and power planning done. Right? All this information you will give to the tool. That is called as floor plan information is given to the tool. Now what happens during optimization, during in the physical aware synthesis, during optimization, tool does rough placement of cells. So tool will do rough placement of cells, right? Not exact placement, but it will, tool is going to do rough placement of cells. During synthesis only it will do. So all the standard cells are placed here. During synthesis only they are placed. Roughly standard cells are placed. Now whatever net delay my tool is obtaining, right? Whatever my tool can, now my tool knows what is a net delay, what is a net length now. So my tool will obtain RC values from TLU plus. Then it can do better optimization, right? So it can do better optimization. So the correlation between logical, physical aware synthesis and final routing stage is very strong. Means we have done better optimization here only by considering the real net delays, right? So correlation between, I'll write physical aware synthesis PAS and routing stage is good. For that reason, we will use physical aware synthesis. But still, sometimes we use logical synthesis also. Why? Can you tell me? Then when we use physical aware synthesis, and why the tool also has flexibility of using logical synthesis. So why we should do that? Yeah. Can you tell me why that is required? Why till logical synthesis is required? Be fast.
It will optimize the logic better area for
When we don't know the RC values perfectly.
Actually, it is technology
RC value
independent.
is known when when the cells are placed, right? Automatically RC values are there, right? In the file. QRC file, RC values are there.
Actually, before logical synthesis, it is technology independent. After logical synthesis, it is technology dependent.
No, that is not the answer, right? Whatever stage is fine. What is there in that? Even yeah, can you tell? See, the reason is, see, you should get this floor plan information, right? So how to get this floor plan information? That is very important. Okay. So you should get this floor plan information first. So how do you get this floor plan information? See, you should do physical aware synthesis, means you should be having floor plan information. See, at least to get a floor, to do floor plan, to create this core area, right? How do you create a core area? Based on utilization, correct? You will create this core area based on utilization. What is utilization?
The area of
Utilization means what is the you will create core area like this, right? Standard cell area plus
Core area.
plus macro area by utilization.
Yeah.
That is how you create the core area, correct? This is the equation for core area. So core area is nothing but standard cell area, macro area by utilization. So you should be knowing standard cell area. So if you want to know standard cell area, then you should be knowing how many standard cells are there in your design. Then only you can create this floor plan. Or else how will you create this floor plan? You can blindly create this core area how much ever you want, right? You cannot make very big or you cannot make very small. There should be some estimation, right? How much core area you should reserve to your block. So to know that, you should be having what is standard cell area, right? So for that reason, logic synthesis is required. That will give you how much cells you have in your design, even without floor plan information. So for that purpose, logic synthesis is required. Well, see, every time we need not to go for logic synthesis because floor plan information can be even obtained, means how much core area you want, that you can obtain even from the previous project information, right? Every time industry will not do the logical synthesis. For example, you have a block, a GPRS block. The same GPRS block is also implemented in the previous project. And in the previous project, you know what is a block area. Obviously, you will not use same area because this time RTL is going to change. A little bit extra components are added to your GPRS things. Then hardly your area may increase by 10%. Right? What was the previous project area? You take it, add 10% area to that, and that much area you can reserve. You need not to always go with logical synthesis. So logical synthesis is required to get first floor plan information. Because to do floor plan, you should be knowing how much area you want. So to know how much area you want, you should be knowing standard cell area. To know standard cell area, you want standard cell count. Then you should go for logical synthesis compulsory at the beginning. But
So
always
if we
not
do
necessary.
physical aware synthesis, then we don't know the count.
Yeah, please tell me.
If we do physical aware synthesis, we will get to know the count or not, sir. How many standard cells are there, macros are there?
But your physical aware synthesis, you cannot start without floor plan, right? You will after synthesis you will understand how much cells are there, how much macros are there. You will get to know. How do you start physical aware synthesis without floor plan? To do floor plan, you want this cell information, correct? Then first to do logical synthesis. By using logic synthesis, first you create the floor plan. Then go for physical aware synthesis. Right? Yes, after physical aware synthesis, you can get the count, obviously. But you cannot start physical aware synthesis at all, right? Without floor plan. Yeah.
Sir, both methods we have to do.
Yeah, at the beginning, logic synthesis is required because then only you can create your core area, correct?
Yes, sir. If we know the information before itself, we can go for a physical synthesis, right?
Yeah,
Directly.
that is what I mentioned, right? If you know what is your floor plan from the previous project experience. In the previous project, the same area, same block was used. Then logic synthesis is not required. Then you can directly use that area. Hardly adding some 5% or 10% extra to that. You can go with it.
Sir, we answer it like, sir, every project has stages, no, sir. Like RTL doesn't come all at once. It will be happening concurrently, you know. So for the first installment, we do logical synthesis. Afterwards, because the RTL installment will not change that much, we can start with physical aware synthesis.
Yeah, good. Even that is also right thing. Yeah, correct. That depends upon the company, right? What method they use. See, what one of the student has mentioned, even the right logic, like project happens in 3 phases: P1, P2, P3. So P1 is a starting phase of project. So in P1 stage, we can do logic synthesis and we can create the floor plan. From P2, we can only depend on physical aware because we already know what is a floor plan, right? So to create this floor plan, we should be knowing cell count. So even though we will get cell count after physical aware synthesis, but to start physical aware synthesis, we need floor plan.
Sir, in industry level, which method is used most?
See, it depends upon the project. It's not about industry, right? If in project has the previous block information, so they will directly get it from them. Okay.
Okay.
If the project is very new, for example, if you take Intel i7 processor was there, they are doing the next version. i5 to i7 they are doing. i7 has almost all the blocks which was having i5. Right. So then directly we can do physical aware synthesis because we can directly use this previous block experience. So it is not only physical information. We use many information from the previous project, like what was the timing there, how they have done the placement there, what was the micro placement. So every information we can get from the previous project, almost.
Excuse me, sir.
But logical, yes, just give me. But logical synthesis is required when you doesn't know physical aware information. That depends upon the project, which project you are using. So if the project doesn't have previous, it's not only about project, right? It's about the block. If this block is very new, it is never implemented in this any of the projects, then obviously you should do logic synthesis first. Yeah, please tell me.
Sir, also in the starting phases of a project, when timing is not that critical, we'll not directly try to converge timing. We can use logical synthesis.
Yeah, that is what I mentioned, right? At the beginning, we can go for logic synthesis because timing is not important. Yes. Yeah, please tell me. Another girl was asking the question.
Sir, we have already in logical synthesis. In that logical synthesis, like core area, die area, we all know. Then why we go directly floor plan without the physical synthesis? In all matter, right?
I didn't understand your question. Please, can you frame again?
Sir, we in that physical synthesis, if we did this logical synthesis, in that we know already core area, like die area, and how much cell counters, utilization, all matter we know. And then why we go directly floor plan without physical synthesis? Can't we go directly floor plan without physical synthesis?
Sir, she is asking in logical synthesis.
So,
anyway, we are knowing the information,
okay,
right?
so
How it's knowing.
I understood your question. Okay, I understood your question. So, what is necessary for physical aware synthesis? That is what you're asking, right? After logical synthesis, directly we can do floor planning, right?
Can't we go directly floor plan directly? Can't we go directly floor plan without physical?
Yeah, we can.
See, logic synthesis, after that you will do floor planning. Again, after floor planning, again you will do physical aware synthesis, then you will go for placement.
Sir, without physical aware synthesis, we can go, right, for placement?
It's just, see, physical aware synthesis is required. Why? Because, right, after logical synthesis, you will do floor planning. You can do floor planning. You can do placement. You can do routing. Okay. So the flow can be like this, right? So that also you can do. What you can do logical synthesis, right? You can do this. So to answer, first I'll answer her question, then I'll come back to. So first you will do logic synthesis. Okay. Then you will do floor plan. That is how your institute would have taught you, right? Floor plan. Then you will do placement. Then you will do routing. CTS, sorry. Then you will do CTS. Then you will do routing. That is what your question, right? Why we should not use this method, correct?
Yes, sir.
Yeah, sir.
See, the reason is, see, placement has optimization techniques, correct? CTS has optimization technique. Routing has optimization technique. Okay. So what type of optimization your placement tool will do? So during placement optimization, tool will do better placement to reduce the routing length. So tool will fix DRV, so max cap and max chance violation. Okay. Tool will fix setup and hold violation by swapping the cells, HVT to LVT, RVT, like that. So during CTS, what tool will do? So tool will do optimization in terms of skew, clock skew, to fix setup and hold. During routing, what tool will do? So tool will see that I am routing with the best possible resources, right, for the time critical paths. So which are time critical paths? Route with higher metal layers, which is having less resistance. So none of this optimization will include, right, logical restructuring. Logical restructuring means use different types of gates, right? None of these methods will include this logical restructuring. None of this will use register retiming. None of this will use register optimization or multi-bit banking, I can tell, right? multi-bit banking. There is a method called as multi-bit banking. So all these type of are auto-on grouping. Auto-on, all this synthesis optimization technique, only synthesis tool can do. Now, during logical synthesis, right, you have a floor plan. Sorry, you don't have a floor plan. You have a timing. In that timing, you had a net delay. This net delay was actually after placement, this net delay was 10 picosecond. But during logical synthesis, this net delay was only 2 picosecond. Why this is a difference? Because during logical synthesis, your tool will use wire load model. After placement, your tool will use TLU plus file or QRC file, because here you know the net length. So here you will get actual net delay, that is 10 PS. But during logical synthesis, your tool was using wire load model, that is not accurate. Here net delay was 2 PS. Here timing is met. Here timing is not met because your net delay got increased. Now during placement, if you want to do all this optimization, that is not possible, because you already reached to the placement stage. Now if you want to do all this optimization, because you cannot meet the timing, because net delay is more, you cannot do that, because these techniques can be done only during synthesis stage. So why your synthesis tool has not done all these things? Why it has not put this much effort? Because here net delay was less. Why? Because here your tool has used wire load model, but here net delay is more, because here your tool is calculating actual net delay. Then the correlation is lost. That is why physical aware synthesis is required. You understood? Even though every information is there directly, why we should not go with this flow? Why we should, after floor planning, why we should do physical aware synthesis? So during physical aware synthesis, what happens? All this optimization has been done here. So then in placement stage, we will start seeing better results. That is why it is required. You got it? The answer?
Excuse me, sir.
Yeah, tell me.
Sir, in logical synthesis also we can do register retiming auto-on grouping, right?
Yeah, you can do.
So optimization techniques we will be doing in the logical synthesis also, right?
Yeah, but here tool will do optimization only it is violating, right? But here net delay is less. Why it will do all this optimization?
Okay, that will be more accurate compared to the logical, right?
Yes, but during logic synthesis also all these optimization techniques are done. But a tool will do only if it is violating, correct? If it is not violating, tool will not do. But here it is not violating because wire load model is using less net delay, but actual net delay is different. So here timing is met, but here timing is not met. So tool fails to do all this optimization here because here already you have better results. Your tool feels okay, I have better results. But tool will do all these things during logical synthesis also. Yeah.
Okay, sir, understood. Thank you.
Yeah. So I felt it is very good interaction, right? Like, good.
So one small doubt.
Yeah.
Sir, there is something called the SPG flow method. Physical aware synthesis comes
Yeah,
under
I will discuss all those things during the interview question because I cannot waste more time in discussing one topic. Okay, SPG flow, fusion compiler flow, right? You have different flows for that, right? So we'll discuss that. Yeah.
Okay.
So DC compiler uses SPG flow, right?
Yes, sir.
So I'll discuss this. So during our actual discussion. Okay, next question, right? So SPG is just a type of flow, right? What is the full form of SPG? Synthesis to physical guidance, right? So that is just a flow where your DC compiler uses that to implement this physical aware synthesis. Okay. You have different license for that again. Okay, so to get all the routing layers of a net, how do you get it? Any command you will use?
So by using a dbget command.
So how many of you are aware about the dbget commands? Everyone know about dbget commands?
No, sir.
No, sir.
So at least you people know synopsis commands, attribute commands.
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
Yeah.
Sir, get attributes, get layers.
Yeah.
Is that
So
thing?
and then that is good. But what I want to mention here is every company will not use synopsis. It is good even though you know cadence, right? Cadence should be also be known. Then it is very good. Or else it will become a little bit difficult to clear the interview. So many companies nowadays ask for Innovus. So you should be knowing Innovus commands.
So, sir, in this tool, which we can prefer, sir? Cadence or synopsis?
See, both should be known for different purpose, right? As I told, synthesis requires synopsis, but physical design requires Innovus. And again, if you go for timing, right, that requires synopsis. So for physical design, Innovus is good. Innovus should be, you should be knowing Innovus. Okay, see which company you can explore, right? Which company uses cadence? Can you tell me which company uses synopsis? That is very easy to identify.
AMD, sir.
AMD.
AMD uses
Synopsis.
Cisco.
synopsis, then Intel,
Twist
right?
global.
Intel uses that.
Samsung.
No, Samsung will use cadence only.
Twist global, sir.
Quest Global is not a
Company.
Quest Global is not a product based company, right? It's a service based.
Vast is correct.
Yeah.
Marvel Technologies, sir.
So all those are not a product based companies. They are service based companies. So probably
So instead of that restore design, you can do source design.
yeah. Please tell me.
Instead of that restore design, we can give a source design also, right?
No, source design will not work. How it will work?
Yeah, actually I am working on Innovus, but their restore design is not working.
Okay. So no, you have two types of Innovus. One is stylus and one is legacy. So I am using
Yeah,
legacy now. Legacy uses restore design, but
okay.
stylus uses read DB. So there is no source design. Probably your companies would have created the wrapper around that.
Okay.
So if you're working in any company, right, they would have created a wrapper around. Say, for example, if you use source design, that is a alias for restore design. I think there is no command with source design. I don't know whether that is there, right? That the company has done or not. I don't know. Okay, so now, so you have dbget command, right? Dbget, right? So dbget has three types. One is a top. What is next? Select.
Head.
Next one is get,
Head.
right? See, top means whatever is from the from the design, right? From the netlist, whatever you're seeing from the, I can just tell you whatever you're seeing here, correct? Whatever you're seeing on this right side, right? All these things you can get from the top. So top means it's like floor core area. So what is in core area? Macros. What is in core area? Your cells, standard cells, ports. So everything, if you want to get, you should come from the top. Select means you can get the information about whatever is selected. So head means to get the library information. If you want to get any information from the libraries, then you can use head. Right? So top. So you can use the command like this, dbget. So if you use tab, right? So if you use dbget top dot. So if you use tab, what will come under the top? It will show everything. Top dot net, right? Net dot name. So give me all the net names. What is present in the design? Right? So top dot net not name. So I will take one net. Okay. For example, this net I will take. Okay. So this net I am using. This net. So now this net would have made up of many routing shapes, right? Like if you have one cell here, another cell here. So this net would have done by using many routing shapes, right? You can take this is a one. This is, you assume that this is made up of M1, and next you have M2, and now again you have some M5. This is M5, and again you have M4, and again you are connecting with M1, right? Like this. This is M1. Some name, right? M1. Okay. This M1. So all these things are. This is one complete net. From here to here, it is one complete net. The net is called as N1. But this net is made up of different routing shapes. So from here to here, you have M1. From here to here, you have M2. From here to here, you have M5. From here to here, you have M4. From here to here, you have M1. Now, what is my question is, I want to get on what are all the layers this net is routed. How to get it? See, if you go like this, right? If you after nets, if you tab, if you use after net, right? If you tab, you will get what? Wires. So what synapse cadence will do? This each routing shape is there, right? This routing shape is called as wire. This routing shape, right? This is one wire. So this is one wire. This green color is one wire. This again pink color is one wire. This light blue color is one wire. So this one net is made up of different wires. This each and everything is called as wire. This wire, this is wire, this wire. So your synapses will call it as a routing shape, but your cadence will call it as wire. So one net is made up of all these things. Now, what is happening here? You want to get all these layers, right? How to get all these layers? So if you go here, right, wires dot layers name, so you can get it. But for which net you want, that is important, right? First, see all these attributes: top dot nets dot wires dot name, fuse tab, right? Layer dot name. This is present inside what? Net, right? It's present inside the nets. Okay. First, I want net name, right? First, select the net name. How to select net name? Use dbget top dot net name and use a net name here. One net name use. Then again you use dbget. First, what this is doing? This is only getting the net name, right? This I have used only to get the net name. Okay. Then after that, I'll use again db get. Then I want for this net, I want what? Wires, and I want layers for that. So, but that wires dot, see, this is, now my pointer is pointing here. This is called as P naught. My pointer is pointing at the name, right? This is a net name. So my pointer is pointing here. But I want layers, wires dot layers. Wires dot layers is not present in name. So wires dot layers is present in nets, right? I should point one step back. Then I'll use minus P1. I'll use here minus P1. P1 means I'm using one more db get. This db get will continue from here, from nets. So this I have used only to select this net. This I have selected, done. Nets dot name. But actually, I should, for the nets, I should get wire, right? That wire is present inside nets. So my pointer is pointing here. This is called as P naught. I don't want to point here. I want to point here, nets. Right? Then what I will do, I'll use minus P1, means point here. So from this use dot wires dot layer names. So it is showing, right, what are the layers it is using. So this net is made up of all these layers. Metal 2, metal 1, metal 1. And if you want to know the net length, right, then you can use, instead of layer name, you can use layer dot anything you have called as length.
Width we have, sir.
So again, you can give a bracket in first dB and LL length. Then you will get length.
Wire. So wires length you can use. Yeah, wire length you can use. It's not present in layer. You can use wire length, right? So first, what you had here, M2, right? This M2 is routed for 0.91 micrometer. This M2 again is routed for 0.2 micrometer. This metal 1 is routed for 0.2 micrometer. This metal 1 is routed for 0.19 micrometer. Again, this metal 1 is routed for 0.4 micrometer. So like that, right? In industry, you should be in a position to get all this information, right, by using db get commands or any commands if they ask. So you should be in a position to do this. This is for net length. This is for layer dot name. Right? So you should be in a position to get this. Or you can use one more command, right? You have one more command. Instead of using db get command, you have one more command called as report route minus net. So this will give you all the split up properly, right? So what was the net length I used? So you have a command called as report route minus net, and you can give the net name. This is a net name. So this command will give you all the split up. So total, this is the split up, right? Total it has two layers, M1 and M2. So M1 is routed for this many micrometer and M2 is routed for this many micrometer. Means it is, this command gave you detailed information, right? Length, like M1 is, if you use layers, right? Layers dot name. So M1 is 0.2, another M1 is 0.4, 0.6, 0.79, right? So M2 is 0.2 plus 0.19, right? So that information you will get here directly. 0.79 for M1, 0.39 for M2. So you can use a command report router. So as a PD engineer, you should be knowing at least to get all this information from the tool, right? That is what I want to mean here. That is what I took this question. Not only this, you should be handling this dbget commands in a flexible way so that you can get any information from the tool, whatever is asked.
Sir, these commands differ in Fusion compiler and ICC2 also, or same commands?
No, that is different, right? Again, Fusion compiler uses attribute commands. So you have like get attribute, get underscore net, and you should select the net. Like that, they have different commands there. Again, Fusion compiler is different, and this is different. See, again, Cadence has two types again, right? Cadence has use Cadence, right? Cadence has legacy mode and Cadence has stylus mode. Okay, these commands again they will change with legacy and stylus. See, legacy uses a dbget commands. Stylus uses a get underscore db. Get underscore db like this. But legacy uses dbget. So again, this format is different again. Get underscore db is different. So many company uses legacy, but few will use stylus. And you can use convert. See, if you know only stylus commands, if you don't know what is legacy commands, then you have that option also. What you can do is you have eval common UI. Means common UI means legacy stylus. Common UI means it is stylus. So one more name for common UI is stylus. This is common UI. So you have this conversion method. For example, I have worked till many years. I worked only in stylus. I didn't work in legacy. Then I can convert that. I have conversion option here. So eval common UI. What you do? You use get db, right? Get db. Get db nets and net name. This net name I use. Then again I have to use get db. This is stylus method, right? This is not the legacy method. I know only stylus, but I am using stylus commands in legacy. This is legacy tool I have opened in legacy mode. Right? So while opening the tool only, you should decide which mode you want to open. So I have opened the tool in legacy mode now. Okay, now dot layers dot name.
Sir, commands also difference in legacy and stylus?
Yeah. As I'm mentioning here, right? It uses get db get. This will use get underscore db. What is the mistake I have done here? Get db nets. Here dot ys dot layer dot name.
Sir, hyphen P1 you may have not given.
That is not required in this. In this, it is not required. It is like okay, stylus. Some difference is there. I'll just get back to you after this. Right? So this is this is a stylus command, right? Like this. So this stylus command, I am asking use eval common UI means I am using stylus command in legacy mode. So if you know that, you can convert it.
Okay.
That is what. So you need not to be knowing both the things. So if you know legacy, then in stylus tool, if you get, then you can use the legacy commands. by using eval legacy command. If you know stylus, if you're using legacy tool, then you can use eval common UI and you can use it. Right? That you can do both guys possible. So next question is methods to fix antenna violation. Right? What is the methods?
Sir, will you be covering these kind of examples in your full course also?
Yeah, please tell me.
Sir, will you be covering these kind of command examples in your course also? Complete course? Any other examples in the course which we will be taking?
Yeah, see,
This,
main course, see, companies are asking directly commands nowadays, right? So we
yes,
should focus
yes.
on this also.
Yeah. So I am not aware of the inverse commands. So we will be covering such commands in the course, right? Not only this. Apart from this, we will be covering many other commands also.
Yeah, correct.
Okay.
See, our training is based on Innovus only, correct? We are not using Synopsys tool because Synopsys, I know many students know Synopsys, but nowadays many interview opportunities are based on Innovus. Okay.
No, sir. Yes.
So how to fix antenna methods, right? So layer hopping, and one more method is what?
Insertion diode.
Insert antenna diode.
Putting
So now my
WD
question is,
Reverse bias diode, nearby gate.
yeah, correct. So that is what the same question. So where you will do layer hopping, right? Layer hopping means what? Change the metal layer to higher metal layers. For example, I have mentioned here, right? So for example, this is the cell which is A. This is A pin or this is Y pin, right? This cell is having A pin. Means this is the input pin. This is the output pin. So how does layer hopping I should do here? So I should first check what are all the layers used for this, right? How many layers? So I am having layers from here ranging from M1 to M5, right? So in this net, total in this net, I have layer from M1 to M5. So here it is used M1, here we are using M4, here we are using M5, here we are using M2, here we are using M1. So what I should do is I should use one layer here, which is highest layer than all these things. Use M6 here, somewhere here, you do it. That should be done near to the gate only, right? You cannot do layer hopping here. Not at the output pin. At the input pin, means near to the gate you should do. So use one layer here. So what you do, instead of using directly M1, what you can do is you can use M5 here. Again go to M6. So this is M6. Then you use M6. From M6 you use M1, right, to connect here. Or use M1 like this and connect here, make a connection. So now this is M6. So near to the gate, I am going to the highest layer, which is already used here, right? You should see what are the layers used here. So you should go higher layer than this. So this method is called as layer hopping.
Sir, if you pin near pin A, if you have high metal layer is presented, what will do, sir, that time?
So if you have M7, right? For example, you have M9, right? And M9 is already used in this entire routing. M9 is already used. So you cannot use more than M9, correct? So layer hopping fails here. Then you go with antenna diode insertion. So your antenna diode, again, you should use near to the gate only, and you should make a connection to this gate, right? Then you can go with antenna diode.
Okay, you always prefer first metal hooping and then we'll go to antenna diode.
Yeah, antenna diode will add the load on this pin, correct?
Yeah.
This pin capacitance will add the load on this pin, and adding the load will affect your timing also, correct?
So is there any ratio for
Metal width is
the
more.
antenna ratio?
If metal width is more, if you have more metal width, for example, you have used NDR for clock nets and you have more metal width, then one antenna diode will not fix a violation. You should have 2 to 3 antenna diodes, right?
What is the ratios that we need to consider about the fixing of antenna diodes?
Now, please be a little bit ask once again.
Based
please
on
repeat
how
your
much
question.
based on how much ratios of antenna violation you need to go for antenna diode, and based on how much antenna ratios you need to go for the layer of this.
See, first you should check for antenna rules, right? You have antenna rule. Which type of antenna violation you're getting? The antenna rule will clearly mention that what should be your ratio, right? Your antenna metal to gate, right? What is the ratio you require? And how much gate you have to improve. Right? Based on that, you should take a call. How much antenna diode you have to insert. So we cannot tell directly. So we should check with the rule. Right? What rule it is violating? There is different rules again, right? Cumulative rule, metal width violation rule. So we should check which rule is violating. From which rule it is violating, then we should calculate that. So already we have gate here. We can check what is the gate area of antenna diode in the left file. Already I have gate here also, and I can calculate what is the metal area. So metal area by this gate area, I can check what is the ratio. And to fix this violation, how much gate area I want, how much I have to increase, how much gate area I should. For example, if this metal area is, you assume that 100 micrometer, and your gate area is, right, your gate area is some 5 micrometer, right? But what is 100 by 5? It is 20, right? But your antenna ratio should be less than some 10, value 10. Then what is the gate required here? Gate required here is at least 10 micrometer gate you want. Then 100 by 10 will be 10, right? So then how much 10 micrometer gate you should add here? So then you should select antenna diode which is having at least a gate of 10 micrometer, or add 2 to 3 antenna diodes. That is required. That depends upon this rule, right? You should check the rule. Which rule and what is the antenna ratio required. Okay, see, I'll take only one more question. After that, I'll stop because we are exceeding the timing. Like, so if you have setup and hold violation, how do you fix? Right? Any answer to this?
So for
Swapping or upsizing or adding buffers.
upsizing we are doing, and swapping HVT to LVT for setup, and inserting the buffer.
Actually,
Both are
we
violating.
didn't get same violations in same path.
You
Setup
can
and
get. Why
hold.
you cannot get? See, for example, you are having setup violation here, right? In this path, you are having setup violation. The setup is violating by minus 5 picosecond. You assume that setup is violating by minus 10 picosecond. And hold is also violating, right? Here, hold is also violating by minus 2 picosecond. So both can violate in the same path because setup is checked in different corner, right? Setup is checked in slow corner, and hold is checked in fast corner. The cell delays are different in both the corners, right? So now, in the same path, both are violating. So how if you try to fix setup by the upsizing or by VT swapping, your hold starts violating. If you start fixing hold, your setup starts violating. Then how do you fix this?
Sir, we see this issue usually on the lower tech node, sir. So this is mainly due to crosstalk, sir. So if we fix crosstalk on the path, we'll get benefit on setup as well as hold.
Yes, good, right? Check for crosstalk because crosstalk will either affect hold or setup. Right? It will not affect both. So if you fix crosstalk, hold may violate, right? Why it will not violate? Hold will violate, obviously. If you improve anything here, any delay is improved, this will start going down, correct? So crosstalk will also affect that.
Sir, as you said, setup is checked in slow corner and hold is checked in fast corner. So both may occur to the same net. So what we do is we'll try to fix setup with enough positive slack so that when we fix hold and that positive slack regresses, it doesn't affect setup again.
That how do you fix that? Right? When you fix the setup, hold will go wrong, right? Automatically start going wrong.
Sir, uncertainty.
Uncertainty is fixed, correct? You cannot change uncertainty unless and until it is approved by the higher management.
Useful skew.
Useful skew is also not good, right? If you improve the, if you delay the clock for capture flip-flop, your hold will violate. So useful skill, you also will, if you try to fix one, other will automatically get violated.
We will check the first next any next pass it is violating or not, and if it is not
that is
violating,
okay. See, that is okay. That is only useful skill, correct? So what you want to see is you will check. For example, you have clock tree like this. You will check whether next path is violating or not. If you have a margin, then you will add the buffer here. Okay, this is good for setup, but this is not good for hold, correct? Hold will start violating for this.
Multi-VT optimization.
Now, what do you mean by multi-VT optimization? So the solution is, I don't want to waste
It
time.
will be balancing.
The solution is, if this type of violation you are seeing more, see, one or two paths, see, there are few cells which is having different cross corner effect, right? Less cross corner effect. For example, this is a cell, right? You assume this cell, like you have AND gate, and AND gate is connecting to OR gate. This type of thing is present in your here, right? You have this type of thing is present here. So in the setup corner, this is showing more delay, like it is showing a delay of 20 ps. But in the hold corner, this is showing a delay of 5 ps. Okay, this much difference we cannot see. Okay, 10 ps. It is showing a delay of 10 ps. And this is OR gate. This is showing a delay of, you assume that it is showing a delay of 25 ps. And in the hold corner, right? In the hold corner, the same cell is showing a delay of some 12 ps. Now, instead of these two things, you replace by only one cell, like AOI gate, right? You have AOI gate. Replace with that equivalent AOI gate. If you have. AOI gate has other two terminals also, correct? This is also there. This is called as AO, and you have, and or you have, correct? And this you can, if all the three pins are not required, one pin, it is not required, you can connect to ground. This you can connect to ground. And this AOI gate is showing very less variation, right? In the setup, it is showing some 30 ps delay, but in the hold, it is just showing 20 ps delay, right? Here, the difference between cross corner is very less. So here, if you add the delay here, right? In the setup, it is showing the delay of 45. Here, if you add, it is showing delay of 10 plus 12. It is 22 ps, right? But if you, instead of using two gates like this, if you use only one AOI gate, in setup it is showing 30 ps delay, but in the hold it is showing only 25 ps delay. So the cross corner delay change is very less. For setup, why it is showing 30 ps? Because it is tested in slow corner. For hold, it is tested in fast corner with few voltage and few temperature. Here also few voltage and few temperature. So select a cell. First of all, replace the cells with the appropriate cells. If some pins are not used, right, connect to ground. So do some logical restructuring so that you select a cell which is having less cross corner effect. This is the first solution.
So then what about congestion?
Congestion, why you expect that congestion is always there, right? Then you should do better floor planning.
Sir, if you have more pin density, automatically you get the congestion also, right?
Yeah, you should do better floor planning then, right? See that you spread the cells near to this area. If timing is important, right? Spread the cells, right? Move the cells here and there. If you have congestion there.
What is the command to implement these techniques, sir?
You should change the cell, right? Change the cell. Go and link the cell. Different cells you use. Disconnect, create instance. All those things you can do. Create instance, right? You can create a AOI gate. Disconnect the net. Connect net. Right? You should do manually. You should disconnect and create it. Not automation, right? If one or two paths are there, right? You can use this type of method. So use the cell which is having less cross corner effect. Or what you do is, if you are having more paths, like 1,000, 1,500 paths are having same issue, then see that most of the cells are coming in the common path, the common clock path. For this both paths, right? You see that most of the cells are coming in on the common clock path. What is the advantage if you have like this? If most of the buffers are coming in the common path, what happens? D rate will get cancelled, right? So D rate will get cancelled in the form of CRPR. So I hope everyone knows how to add the D rate. So how do we add D rate? During setup, right? Here we will increase the cell delay. In this path, we will decrease the cell delay. That is how we add the D rate. So during hold, right? So what we will do during hold, here we will decrease the cell delay. Here we will increase the cell delay. So D rate is always bad for setup or hold. So if you remove this D rate, right? So your hold will also improve, your setup is also improved. How to remove the D rate? So to remove the D rate is only option is see that most of the clock cells will come in the common path. If most of the cells are coming in the common path, right, D rate will get cancelled in the form of CRPR, clock convergence pessimism removal, or CPPR.
Clock reconvergence pessimism.
Clock reconvergence pessimism removal. So in that, most of the all the D rate will get cancelled, so that your hold will also improve, your setup will also improve. So you can use these two methods to fix a violation if you have both setup and hold in the same path. So that is why H tree is important, right? In H tree, almost all the cells will come in the common path. You have less effect of OCV, on-chip variation. Okay, see, I will just stop the questions here because we are exceeding the time. So just I can show what is our syllabus, and this session will go for 2 months. Okay, it is like weekdays and weekends both. So it is for 2 months. So this is our syllabus, right from synthesis to the routing, timing and STA sign off, and resume preparation, right? To this level, we'll do the interview preparation. So in every topic, we'll take 30 to 40 questions. So a few questions which are very easy is discussed during the weekdays. That is during 2 days in a weekdays we'll discuss, and in the weekdays we will discuss the difficult questions. So total it is for 12 sessions, right? Totally, I can tell it is 12 days of weekdays. See, weekends I have not counted here, right? It is 12 days of weekdays, and obviously means 12 days means we will use 6 weeks, 1.5 to 2 months. Right? This is the schedule what we have, and as you asked, right, we will cover on inverse commands also, legacy and stylus commands. Mainly we will focus on dbget and dbset commands, and few automated scripts on Tickle also we will cover, and main focus will be also on STA, and in each topics we'll take few questions and we will answer it. So at the last we'll end up with low technology issues and real-time challenges on how to do resume preparation. This is the schedule, and this is for 12 sessions, means it is for 6 weeks, means I am counted only for weekends, right? It's weekdays, it's easy questions. I have not counted that. We have 12 sessions, means 12 sessions is equivalent to 6 weeks, Saturday and Sunday, right? So totally you have 1.5 to 2 months sessions. Yeah, this is our interview preparation schedule, and if you have any queries, you can ask me.
What will be the duration of each class, sir?
3 hours.
On weekdays?
Weekdays also 3 hours. 2 days only. It's not all the weekdays. Weekdays it will be only for 2 days.
No, so there are separate classes for weekends and weekdays. I got
No,
confused.
same classes. See, what we will do, easy questions is covered in weekdays. If even few students who are not about, say for example, I take synthesis, right? What is synthesis? What is inputs for synthesis? What is the content of .lib? Right, like that. Easy questions are covered during the weekdays.
Okay.
So difficult questions and challenging questions are covered in the weekends.
Okay,
And
so the classes will be daily.
recorded, and if you want to go through, you can go through the recorded videos. That will be given to you.
So there will be daily classes here.
Yeah.
There will be daily classes. That means.
No, I didn't understand your question.
So you mean there will be daily classes, right?
No, 2 days in a weekdays.
Okay.
And 2
Okay,
days in a
got it.
weekends. 4 days in a week.
Okay. 4 days in a week. Okay.
Sir, class is online or offline, sir?
So you can attend any mode, right? It's your wish. You can choose the mode
Sir,
of.
sir, one more thing. Will we get Innova session also for this course?
Will you get
access to Innova session?
See, that
Daily
you
will
will
get, sir.
talk to the admin, right? We will teach you by Innovus. So you can see if we have less students, we can give, right? But if we have more students, we cannot give to everyone. Then that should be used by time multiplexing, like, because we also have license to for the course also. We are also doing the course. Right? We have course also with us, and we use license for the course also. So for that reason, we can use by time multiplexing. Right?
Because sir, to practice the commands, I mean, we can't practice by writing. Right? We have to type and we have to use the commands on the design. That's what I mean. To get hands-on on Innova's
Yeah,
commands.
you can use it. You can use by time multiplexing. Like few students, they can use one day. Other students can use another day. Right? Like that, they can use.
Okay.
So we'll get the daily mail of this session, sir.
Yeah, please tell me.
How do we access again? We will get the daily mails for this session.
So we
Or
will
continue?
create a link, right? After you registering to the course, we will create a link. We will create a WhatsApp group. In WhatsApp group, we'll share the link to attend the sessions.
Okay.
What, sir, what is the timing of that course?
2 months.
Timing, sir, timing, daily timing.
So it will be 10 to 12.
Okay.
Yeah. Any other queries?
So everything you mentioned except the price of this one.
It is 10,000 plus GST.
Okay, 10,000 plus GST.
Sir, hi sir. I have one question. Sir, every is asking for currently looking for 23, 24 passwords. What about 25 passwords, sir? Actually, what is the exact hiring season for this 25 password students? When can we expect the hiring?
There is even a recruitment for freshers also. Right, but you should be searching thoroughly, right? In everything, you should be searching thoroughly, and you should be skilled. See, how does the industry work? I'll tell you, right? See, even everyone has faced this issue. Even we have faced when we were freshers, right? So how the industry works? The industry will work like this, right? So there are many service-based companies and product-based companies. Service-based companies will acquire the students, hire the students, and they'll send for the projects of product-based companies. Okay, so every product-based company's minimum requires 3+ years experience. Then they are sending as a temporary employee. For example, I have a company and I am sending you to Intel, right? Okay, I will send you with 3 years experience only. Intel will not take less than 3 years. Okay. Now, so every service-based company wants a 3+ years candidate only. They don't want a fresher. Okay. Yeah, please listen. Right? I'll just take your question again. So there are few companies called as IT companies has now entered to the market, like Wipro, TCS, right, L&T. They have. So when these companies will get ODC project, ODC means off the shelf project, right? ODC. Then these companies, these company, they can use any engineers they want to complete this project. So then they may prefer even for freshers. So whenever there is a requirement for freshers, you should be ready with the skill and you should grab it. Right? Because the opportunities for freshers is very rare condition. So once, fresher recruitment will happen like in a flow. Like once a ODC project comes, right, they will hire 50 to 60 freshers at a time. But how many freshers we have? We have freshers more than 300 to 400, right? So you should be having good skills and you should be searching, right? There is opportunities available. You should be searching and you should be thoroughly searching in the website. Wherever there is opportunity for freshers, you can go get in. That is what you can do. So if the ODC project comes for any company, right, they'll surely hire it. You should be waiting till that level. That's the only option to get in, or else you can get in even if they don't pay you the salary also, right? Then you can get in. You can just work as a buffer to one or two projects instead of wasting the time. See, every person has this challenge as a fresher. Even we had it during our initial days, and every person has faced this challenge as a fresher. See, VLSI is always hard for fresher, but if you have a experience, right, it is a they will treat you like anything. So you will receive a hike of even 40% to 50%. Your software will get only 5% or 10%. That is what the difference between fresher and experienced candidate. So VLSI, while they will not prefer fresher, is see they have to invest huge on the tool. Tool is very costly. It's not so easy to get it. It is almost 8 lakhs for 6 months. That too depends upon how much currency will vary, right? Our Indian currency will vary with respect to dollars, right? How much it is varying depends upon that also. So whatever currency we had for last 3 months, that is not there today. It's increased by 2 rupees, I think, right? So if that is increased, right, we have to pay 1 more lakh extra. So cost for 6 months, a company has to pay 8 lakhs to 9 lakhs to get 10 licenses of the tool. So none of the company will get the freshers and they'll simply keep and they'll not train with this costly tools. So going fresher is very difficult, and you should be skilled, right? You have a hope, you skill yourself, be ready, have a good communication, make yourself ready. So whenever there is an opportunity, you have to grab it. Right? That is only option a fresher has.
Sir, if we take this course from your side, will be any placement assistance or?
Yeah, we will give you the placement assistance. If we get any requirement, we will send you, right, the details of the placement.
Sir, any tie-up company have, sir?
So you can talk with admin regarding all these things. Yes, we have tie-up companies. Our placement department is actively working for the placement. So if we get any requirement, right, we will take your resumes and we'll forward to the companies.
Sir, what's the starting date of the course, sir?
That to talk with admin, right? I am not sure about the date because it depends upon admissions also, right? How many are enrolling?
Okay.
Probably next week, right? Next Saturday. From next Saturday, we may start.
Okay, sir.
Excuse me, sir.
Yeah, please tell me.
Every company has different flows, like KT flows or make flow and tie builder like that. That is also explained, sir.
See, flow we cannot explain. If we explain the company flow, right? So we will be fined huge, right? It's their company's role. Right? We cannot even use a single command from that. Okay, that is very confidential, and we should not mention that. So none of the issue cannot do that.
Okay, sir.
That is confidential. If they put lot of efforts in building their flow, and we cannot even show one of the page of that. That no one companies cannot do that. The flow you should learn from the company itself. Okay, that is not difficult, right? Flow is very easy. It's just a few settings you should do for 10 minutes. Right? Flow is set. That's it. It's not very difficult, and we should not do that.
Okay, sir.
I cannot teach any flow like this is Intel flow, this is a Qualcomm. We cannot do that. We should not do that. Thank you, everyone. Right, if you have any queries, right, you can also talk to admin, and you can get our contact number. You can call me. Okay. Thank you, everyone.
We will contact you via the email regarding the next steps as you.
Enjoy. Hi, bro, Sai. Hi, Burj Khalifa. Venkat Bhai, your DP is so nice, so good. Hello, Branda.